Hello, everybody, and welcome to lesson 6.4. We're skipping lesson 6.3, and we're on page 399, and this lesson is on scatter plots and trend lines. Underline the title, please. And what we're learning today is how to write an equation of a trend line and a line of best fit, which I personally didn't know there's a difference. But so if it's a line, our equation will look in this form: y equals mx plus b, which is something I hope you've seen before, slope-intercept form. This number here is your slope, and the last number is your y-intercept. I'll shorten it y-int. And this is where the graph would cross the y-axis, and this measures the steepness of a line. It's rise over run. And coming down to the bottom of the page, if we read this part right here, a scatter plot is a graph. Oh, didn't want to do that. A scatter plot is a graph that relates two different sets of data. In other words, we're pairing up an X with a Y. That's kind of like an ordered pair. Actually, it is an ordered pair by displaying them as ordered pairs. There you are. Most scatter plots are in the first quadrant, which is this one right here, because most numbers are positive. Yeah, that's not that important, but usually we're dealing with positive numbers, so we only need quadrant number 1, which is this part. You can use scatter plots to find trends in data. The scatter plots below show the 3 types of relationships that 2 sets of data may have. The first one is called a positive correlation. Why? Because most points, this is called a scatter plot, by the way, because you're not really connecting the points. You're just plotting them and looking, is there some trend? This one has a positive trend. It's as X increases, the Y values increase. This one looks like it has a negative trend. It means as X gets bigger, Y values are getting smaller. And this has no trend. They're all over the place, so it's no correlation. And this one here is called a negative correlation. So those are the 3 words you probably have to use throughout the text. We're moving on to the next page, by the way, we're skipping this. Nothing on this page. Page 400. We're moving on to page 401 to the top. By the way, you do need a calculator, and so grab one. I don't want you to use your phone. I rather have you use a real calculator so you know how to use it in class as well. Okay, so instructions for each table. So we only are going to do exercise 1. Make a scatter plot of the data. After that, you're going to describe the type of correlation. That is the stuff I was talking about on the first page. Down here, the type, is it a positive correlation, a negative correlation, or no correlation at all? That's what that means, type. So you have 2 parts to answer. Let's make the scatter plot first. And we only need the positive X and Y axis. By the way, the top are your X's and the bottom are your Y's. So we're having all these ordered pairs. 21 goes with 130. By the way, this means that the average price of an item being $21, you would sell 130 items. If the price goes up to $28, you would only sell 112 items, and so on and so forth. It looks already to me like it's a negative correlation, but we'll look at the scatter plot. So these are the ordered pairs we're going to plot. So what your job is, and that's probably the hardest part, is finding out what is the number line look like. On the bottom, I have average price. I want you to make sure you label your X and Y axis. with what's going on. What is the item? What is the quantity? And then the y-axis is the number of items sold. Make room for your numbers here. So now you're looking at the range of numbers. I'm going back to the first, to the x-axis. The range is kind of how far do I go? The highest is 40. I want to start kind of at 0. I don't have to start at 0, but since 40 is not that high, I decided I'm starting at 0 and I'm going up 10s every 2. Remember, your intervals have to be the same. Can't skip around. And then on my y-axis, the number sold, I have to go up to 130. But I'm not going to start at 0, otherwise this will get too crowded. So I'm going to start at 60. I will also use 2 squares each time, so I don't have so many numbers, right? Makes it easier. So I'm going to start at 60 and I'm going up by 20 each time. So that way I will cover all my bases with the highest number. And then here comes the scatter plot. 21, it's about right here, goes with 130. So you have to estimate about right here. Make your points nice and fat. No use making little tiny points, you can't see them. 28, 112, 112, about right here. 36, 30, 35, 36, and 82, and 40, and 65. So look, it's going downward, right? That's a negative trend. So we can, so this is the first part. This is your scatter plot. We're done with that part. You do not have to connect them. And now describing, it's a negative correlation. So what that means is the higher the price, so as your price gets higher, your number sold gets less. The higher the price, the less items you sell. And that is a business consideration when you make a product. Am I making it cheap or expensive? So if I make it cheap, a lot of people can buy it. If I make it expensive, only a few select people can buy it. That's kind of the stuff businesses consider. So this is the question answer totally. Now on the bottom of the page, you're having trend line. When two sets of data have a positive or negative correlation, you can use a trend line to show, let's underline all this. Then when I underline, that's the stuff I want you to study when you study for a test or quiz or reread your notes, right? When two data sets have a positive or a negative correlation, positive, negative, you can use a trend line to show the correlation more clearly. A trend line is a line on the scatter plot drawn near the points that show a correlation. So when you make the trend line, you have to decide which line fits it the best. You want to kind of get most points as close as possible to the trend line, if not on the trend line. Yeah, so that's what we're practicing next. You can use a trend line to estimate a value between two known data values. So let's say you want to estimate what's happening here on with my X value. What's the answer, the Y value? but it don't have a point. It's not part of your data set. When you have a trend line, you can estimate that point. It's called interpolation if that point is on between two known values. Don't worry if those words, if they don't stick in your brain. I haven't learned those words either. I'm just looking at them now. Extrapolation is a predicting a value outside the range of known values. So extrapolation would be if we continue this line, what's happening out here in the future? Usually it's a time thing on the x-axis, usually, yeah? So interpolation, when it's somewhere where you have data points and you're looking for a point between two numbers, extrapolation outside of those points in the future. Not a big deal if you forget. I don't think I'll ask you that, but that sounds good. Work on problem 2. We're on page 402. And by the way, before I continue, I want to show you, I'm going to have to stop for a second. I'm on Desmos. I mean, I'm hoping that you can see this desktop. Let me know if I messed up and you can't see it. I'm on desmos.com and I want to show you how to put in a table yourself to make a scatter plot on Desmos. So up here in the left-hand corner, you see that plus. You click it and it comes expression, node, table, folder, image. We're going to enter a table and it opens up your X sub 1, Y sub 1, your X and Y, and you just type in. So I'm going to put in the numbers we just used on our last problem to make a scatter plot. You just type them and click enter and it just moves the cursor automatically. I guess I don't know what I hit, return, 112, 36. Oh, I just click on it. That's what I'm doing. 82, 40, and 65. So now my graph is probably pretty high up there. Where did it go? I'm going to change my x-axis. I'm going to go a little bit below negative, and then my x's go up to 40. So I'm going to go to 50, cover all my bases. And on the y-axis, I'm also going a little bit below, -3 maybe, and I have to go up to 130. So I'll go up to 140. And there it is, my negative correlation. Zoom out a little bit. So those are those 4 points that you plotted in your, and that's kind of the picture you had, right? You can make it bigger. I wanted you to see how you enter those points in a table. Go back to our, let's look if I'm making sure I'm on there. Yep, I think I am. And we're on problem 2. And now we're going to make a scatter plot and then draw a trend. No, where are we? Yep, problem 2, yep. So now we're stepping it up a notch because we have to not only make the scatter plot, we also have to write an equation. Okay. So make a scatter plot of the data. Then you're going to draw a trend line, use a ruler, and then write the equation. And then we have to find, so let's look, what is this table about? Body length of a panda. So the top is your x's, your age in month. And the bottom, the y numbers, are the body length in inches. Yeah, they measure them at the zoo. They do a lot of stuff to those animals. What is the approximate body length of a 7-month-old panda? Well, you notice they're missing the 7 here. They went 1, 2, 3, 4, 5, 6. That's called interpolation because it's between, I'm just throwing that out there. Is that what it's called? Interpolation, I think that was the word. because it's between those data points. So they miss them on number 7 and they want to estimate what number it could be. So that's where those trend lines and the equations come in handy. The equation, remember, is in the form y equals mx plus b. Why? Because we believe that panda is growing in a linear fashion mostly. Yeah, with a positive correlation uphill. So let's look. Okay, there we are. Now let's look. We got to put the age on the x-axis, which is always the horizontal one. And it's in months. We want to be as specific as possible. And then we start at age 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not writing those numbers. You can just count them and you plot them. I'll write the first and the last. And the body length, in inches. So those numbers, we have to go all the way up to 29. So I decided to go by 5s, and it won't cover 29. We'll just have to go a little bit beyond 5, 10, 15, 20 inches, 25 inches. So the graph will be a little off the chart. It's okay. 1 and 8. Is that about right? No. 1 and, so that's 7.5 about here. 2, 11.75. I'm not going to be too picky. 3, 15 point, close to 15. 4, 16. 5, 1, 2, 3, 4, 5. 20. About right here. 6. 22. 7 is missing. 8, 26.5 up here, and 9, 29 up here. Yeah. So that's my scatter plot. The scatter plot is not connected, but the trend line is. So when you draw here's the question in the corner. How do you draw an accurate trend line? So what do you write here is you need the points on or close. You need as many points as possible, I should say, on or close to the line. So that's kind of what you look. And I don't have a ruler. I never figured out how to make a straight line with this. So I'm just going to, that's always a scary thing without a ruler. So I'm just gonna go like this. Make sure it's straight. You guys use a ruler, please. There's my trend line. Don't go beyond 0 because he doesn't have a negative age or weight. He doesn't have a negative age. So there's my starting point. So that's kind of what it should look like. Yeah. And now that's my trend line. Okay, draw a trend line and write the equation. Here comes the hard part. You ready? I'm going to give you steps. So the first thing is you have to find slope. And what you need to do is find oh no, I'm going to say this so it makes it easier. You're going to pick 2 points. You're going to pick 2 points close to or on the line. So you don't want to pick 2 points that are really far away from the line. So I'm going to say I'm going to pick 1 and, actually I'm going to pick 1 and 8. And I'm going to pick 1, 2, 3, 4, 5, 6. And this one is 6 and 2. 6 and 20, so I'm looking here, 22.2. So now next step is you find the slope between those 2 points. You need to use the slope formula. You learned that in 8th grade, y minus y over x minus x. Change in y divided by change in x. So your y's are the second number, so you have 8 minus 22.2 over 1 minus 6. And that gives you 14.2. Use your calculator. No, I made a mistake. I want to do it the other way around, just to not throw you off, to make it negative. Doesn't matter which way you do it, but let's do it backwards, just so that my numbers are not going to end up negative. $22.2 take away 8, and then 6 take away 1. So if you go backwards, it'll be positive. And that'll be 14.2 divided by 5. And in this case, you can actually divide it. Use your calculator. 14.2 divided by 5 equals, don't forget to hit that equal sign. And then you can round. I'm going to round to 2.84. That's the slope. Okay, so you need the slope and you also need the y-intercept. So the y-intercept I'm going to estimate from my graph. So that's the step 3, estimate y-intercept. So the y-intercept is right here where the graph crosses that vertical line. I'm going to estimate to be about, so this is 5, this is 10, make it 7 maybe. So my equation would be, and then you write the equation. Y is equal slope, 2.84. Then comes the x, then comes the y-intercept, which I estimated to be about 7. So there's my equation that comes from the trend line. Remember, you need 2 numbers to write a linear equation. You need to find the slope, use this formula, find 2 points, and you need to figure out where does my graph cross the y-axis, which is your vertical axis, right? Y-axis. And that number is last. So now last question, part of this, we're almost done. We done the trend line, we wrote the equation. Now we're going to use the equation to approximate or estimate the body length of a 7-month-old panda. So if the panda is 7, is that the X or the Y? It's the X, right? Because remember, X is your age, that's your top. So X is 7. All right, let X equal 7 because that's 7 months, right? And then plug it in here for X. So Y is equal to 2.84. This means he grows 2.84 inches every month. That's what that slope means. And X is 7 months plus the 7. Then that 7 back here means at his birth, when he was 0, when he just came out, he was 7 inches at birth. 0 is your X value at the y-intercept. So 0 age, 7 inches. Now use your calculator. That's why you needed 2.84 times 7 and then plus 7. And then you should have an answer. Let me check it. I had different numbers earlier. So 2.84 times 7 plus 7. I get 26.88 inches. At 7 months. So there you are. That's interpolation. You used your equation to estimate a data point between. So now we know 7 months 1, 2, 3, 4, 5, 6, 7, go up, should be about on our line, should be 20, I'm off. My graph, so this is the reason why these trend lines drawn by hand are not that accurate. I want to show you how to make it really accurate. So I'm going back to Desmos, hope and pray you see it. So remember, I put in the points. I'm going to put in these points that we just played with. So again, I'm hitting table. And the numbers are, I'm going to pause while I put in the numbers. You can do it too. Go ahead and go to Desmos and try it yourself. Okay, so I put in the numbers from the panda age versus, so here's his month and here's the length. And I'm urging you to do the same in practice. And then I'm going to have Desmos write the equation. So I'm clicking underneath on the second line, open a new text box, and now you have to put in the format of the equation. Here's how it works. You're going to type y, and then hit your shift key and your underscore, and that brings up a subscript. It's called subscript 1, y sub 1. And then you have to click off of it to go back in the middle line. And then you find the tilde. On my computer, the tilde is shift, and up in the left-hand corner, it's that round little thing. And then comes the slope, m, and then comes the x, but you have to go shift underscore to make it that sub 1. Click off of it to bring your cursor back in the middle, and then plus b. And now your plot was here. Here, those green points are your data points you plotted, and your line of best fit or trend line is now estimated by the computer, and which is more accurate. So I want to show you down here, it has your statistics. So down here, where it says parameters, that m, that's your slope. So this slope is 2.5. What was mine? I had 2.84. And I'm just estimating because I'm cutting off all those decimals. So I'm using 2.5 for the slope, and b, the y-intercept is 6.7. That's this point right here. See, 6.721. That's your, when x is 0, this is your y-intercept. That's your number down here. Okay. And the other numbers, this r is a correlation factor. And if this number is positive and very close to 1, you got a strong positive correlation, which we do, right? If this number r is not really that close to 1, the closer to 1 this number is, in our case, it's very close, 0.9943. The closer it's to 1, the stronger your correlation. If it's a negative number, it's a negative correlation. Your graph will go downhill. Again, the closer to 1, the better of a correlation is your graph. So I'm going to use this as my equation and then try it again. So now I have slope. So I'll go back to I'm going to go back to my other screen. And I'm going to use the equation I just found with Desmos, which is definitely more accurate than our handwritten graph. But I needed to have you see how to do it in case, you have to know how to do it. And then once you know how to do it, you can use Desmos. So the equation on Desmos, I'll call it Desmos equation, was y equals, their slope was about 2.5x, and the y-intercept was about 6.7. And if I put in for x7 now, 7 months, it's going to change the answer a bit. we're still looking at the panda's length at 7 months. It's going to be 24.2 inches, which is probably better. Yeah, see, even on my graph, the point is below 25. So this was 7 months. If you go straight up, remember it's the key is vertical, straight, and then over vertical. I mean horizontal. You're going to come right below 25, which is correct according to our line of best fit. So that's that Desmos thing. If you're a little confused on that right now, don't worry. I maybe have time in class to go over that with you again. We're skipping to page 405. Skipping a lot. 405. There we are. So identifying whether relationships are causal. Causal means is something causing, I think that's way on top here. Yeah, causation is when a change in one quantity causes the change in a second quantity. A correlation between quantities does not always imply causation. So let's look at these sentences and decide. In the following situations, is there likely to be a correlation or connection? Think of the word connection. If so, does the correlation reflect a causal relationship? Explain. So is the cost of a family's vacation and the size of their house, is it a causal? I would say sometimes, because sometimes the more money you spend on your vacation, you have it. So you probably have it spent also on your house. So most likely, yes, there's a positive correlation, meaning the more your vacation, the higher the value of your house. It could be, I'm careful with that, causal. No, it wouldn't be. No, because no, I would say it's a positive, sometimes a positive correlation. But I think that a lot of people spend money on their vacation. They just want to travel, but they might not have this big house, right? Sometimes. I'll just leave it as that. You have to think of different scenarios. I'm going to not write that word. The B is more clear to me. The time spent exercising and the number of calories burned, definitely positive correlation. You exercise, you're going to burn calories. There's no other way. And does your exercise cause you to burn calories? Yes. Now, does your cost of your family vacation cause you to have a bigger house? No, not causal. So that's just a little tidbit. Next page. What else do we have here? Analyzing a nonlinear trend. So remember we had exponential functions earlier. So we had exponential functions and they're not linear. And remember the form was y is a times b to the power of x. A is your beginning amount, b is your growth or decay factor. So how can a scatter plot show, look, if it's curved? Because curved, if it's really curved, then it's not linear, yeah? So then let's look. I'm not going to do this by hand. So we're going to use a graph. Okay, let's look what the numbers mean first. The table shows the value of Denise's car each year since she purchased it. So the age of the car, 1 year, 2 year, 3 year, 4 year, 5, and Y is the value in thousands of dollars. So this means $28,600, $18,500. You're adding 3 zeros each time. That's what that thousands mean. Yeah, and our job is to graphing calculator, make a scatter plot, then a model is an equation. Yeah, we don't know if it's linear or nonlinear. Most likely it's not linear, otherwise they wouldn't say it here, right? But you don't know for sure when you first start out. So we're going to look at the model, probably exponential, and we're going to write the equation, and then we're going to predict the value after 8 years. Since 8 is not in our data set, we got an extra, what is it called? Forgot the word. Excuse me. Anyways, let's go back to Desmos, and we're going to plot these numbers. We're not using the zeros, that's too much. I just wanted you to see what that means. So let me see if I already started this. Let's see, is this it? Nope. I must have. I'm going to start this. I'm going to pause it, and you guys plot the numbers, and I will too. So I just decided, instead of doing it alone and you guys do it alone, I'm going to walk you through it one more time. You go to Desmos. You got that plus button here on the left corner, top corner. You're adding a table, and X is your top number, the age, 1, 2, 3, 4, 5. Oh, where does my cursor go? And the Y are the value in thousands, 28.6. Wonder why my cursor keeps jumping around. 18.5, it's a negative, it goes down because cars, their value goes down. Uh, 14.1. 4 years, 10.2, 5 years, 8.9. And then you click on the second one. Oh, look here are my points. Now we got to decide. I'm going to change my view, go to the little graph setting, the little wrench, and I'm not going to, you look at all the negative numbers, so I'm just putting in -3 on my x-axis. And then I'll go up to, what's my highest number on the X? I'll go up to 6. And that makes it a much better view. And look, you got a curve here, definitely. It looks like a curve. So let's say it's exponential, right? And then you're going to click on the second line below your table, and we're going to put in an exponential model, like y is equal to a times b to the power of x. So y, but you need that sub 1. So you shift and your hyphen brings it down to a subscript, click off of it to get back, put in your equal sign, then comes a, then comes b. Power is on this keypad. It's this one, a to the power of b, not a squared, a to the power of b, your x, and then sub 1, we have to go again, shift hyphen sub 1, click off of it. I didn't like it. Oh, where are my points? What happened to my points? Oh, these things happen to me and to you. I'm going to pause it and figure out where they went. Okay, so I've been playing with this for a few minutes and it's not working. I have put in the equation y sub 1, and then this is this little tilde a times b to the power of x sub 1. And what would happen down here, you would have your a and your b, which it's not giving me, and it's not forming the line. So, but that happened to me before, and I had to play around and input the data again. Maybe some of you will try it and say, what exactly happens that it doesn't want to do it one time and does it the other. However, I'm going to continue with the lesson and give you the numbers because I've done this in my preparation and it worked. So I'm going to give you the numbers, and then we'll have to figure out next time what it is that's preventing it from working every time. So it'll probably work next time I do it, but it doesn't want to do it now. So it's an exponential model. So we want to find the A and the B, and the computer that Desmos finds it for us. And it is, A was 38. I estimated, I rounded. It had many decimals, and B 0.7. Again, I rounded. So notice it's less than 1. So that's why it's a decay function, right? So there's our model. And now we're supposed to estimate or predict the value of Denise's car after 8 years, meaning X, yeah, is 8. So in our function, we're going to input for X 8 and finding Y, which is the value of the car after 8 years. And so 8, use your calculator, make sure you start here. 0.7 to the power of 8. Remember your power key, it's this little what's it called? Caret. And then if you want to do a little in between, you can hit equal. You're going to have a lot of decimals, so don't retype it. You use your answer key, which is on your calculator, ANS, and then times it by 38. And then hit equal again. You can also put this whole thing in your calculator. If you use the parentheses, just like you see it, it will know that the order of operation is take the power first. I just want you to be sure you understand how that works. Sometimes the calculator is only as smart as the operator. So I have 2.190. So what that means is, because remember the values in thousands of dollars after 8 years, the car is worth, now you can write the real price, $2,190. So there's our model, and I wish I could have shown you that on Desmos, how I got this equation. It's so super easy, but you can't, I had to do it twice earlier, and it finally worked. I don't want to spend more time in class. We can try it out. And I'm sure there's some of you who will say, man, I figured it out, hopefully. Homework, page 407. Number 10, 11, and 12. Make a scatter plot. Data. Here's your X, here's your Y, right? Latitude, average maximum daily temperature in January for northern latitudes or regions, right? So these are the numbers you're going to plot here on your coordinate plane. Make sure you write down what it means and come up with a reasonable scale, these intervals, right? Then you're going to draw a trend line on the scatter plot, and you're going to write the equation. It's going to be linear, hopefully. I want you to do it by hand first, and then you can use the Desmos to see if you did it right. And then you're going to predict the average maximum daily temperature at a latitude of 50. So you're going to put in for X 50 and find the Y. And that'll give you that average temperature. Okay, and now next page. Next page, we have number 13. Where are we here? Vocabulary. This is those interpolation and extrapolation. Let's see if we understand it. Yeah. How do you decide whether to use one or the other? Maybe you understood it. Not that important. Number 15, an error. Okay, the student says this. Is he correct? No, obviously not. There's an error. You have to explain what that error is. If you really don't see it from the table, I would actually plot the points. You can actually plot those points on Desmos and see what the scatter plot looks like, just if you don't see it from the table. He says it's a student says the data is negative, so he says it's going downhill, the scatter plot, right? So if you see it, great, what's going on? If not, plot them. And then on nothing on the next page until the very last page, which is, sorry, I'm moving this around like crazy. We're on page 410. And I'm going to ask you to do the challenge, which is really not that much of a challenge, but try it. You're going to do everything I taught you all together. Okay, you're making a scatter plot. I want you to use Desmos. And I'm not sure if it's linear or if it's exponential. Actually, I bet it's going down. No, they're going up. Oh yeah. The speed of a car versus the stopping distance, a very important concept for law enforcement to figure out how fast the car was going. They measure the stopping distance. They measure the tire marks that the car made. So then they know how fast the car was going when they hit something. So the speed and the stopping have probably a positive correlation. Look, yeah, as the speed goes up, the stopping distance goes up. You're going to read all of these. I don't want to go over it because you guys are readers, and see if you can answer each part of the question. I don't understand that last part here. This one is tricky. I'm not quite sure what they're talking about, but maybe we can figure it out. Let's challenge, okay? So have a good one. Sorry about Desmos not working. And I will see you later.